Welcome to this scientific lecture on cognitive TRIZ, a fascinating methodology that transforms mental contradictions into breakthrough ideas. Today, we'll explore how this powerful framework can revolutionize your problem-solving approach. Let's begin with the fundamentals. TRIZ stands for Theory of Inventive Problem Solving. It was developed by Altshuller, a Soviet engineer and scientist, who analyzed over 200,000 patents to identify patterns in innovation. TRIZ is not just another brainstorming technique. It's a systematic, scientific approach to innovation based on empirical analysis of successful inventions throughout history. Altshuller discovered that the same fundamental principles appeared again and again across different industries and time periods. This led to the formalization of 40 inventive principles. The core insight is that technical systems evolve according to predictable patterns. Innovation is not random. It follows laws that can be understood and applied. Now, what happens when we apply TRIZ principles not to technical problems, but to mental processes themselves? This is where cognitive TRIZ comes in. Cognitive TRIZ extends the TRIZ methodology to cognitive challenges. It helps us resolve contradictions in our thinking, overcome mental blocks, and generate creative solutions to abstract problems. Just as technical TRIZ resolves physical contradictions in engineering, cognitive TRIZ addresses contradictions in our mental models and belief systems. Let's dive deeper into the concept of contradiction, which is absolutely central to TRIZ methodology. Here's an important question. What makes a problem truly difficult to solve? Is it complexity, lack of resources, or something more fundamental? The answer is contradictions. A problem becomes difficult when improving one aspect necessarily makes another aspect worse. This creates a seeming deadlock in our thinking. For example, in materials engineering, we want materials that are both strong and lightweight. But traditionally, stronger materials are heavier. This is a classic technical contradiction. TRIZ identifies three main types of contradictions, each requiring different resolution strategies. First is the administrative contradiction. This is when a problem seems completely unsolvable. We don't even know where to start. The solution here is to reframe it as a technical or physical contradiction. Second is the technical contradiction, when improving parameter A makes parameter B worse. For instance, making a car faster reduces fuel efficiency. Third is the physical contradiction. An object must have contradictory properties simultaneously, like an umbrella that must be large when open but small when closed. Now let's apply this to cognitive processes. What do contradictions look like in our mental world? Consider this mental contradiction. To solve complex problems, we need deep focus on details, but we also need broad awareness of context. Focusing too narrowly causes tunnel vision, but thinking too broadly prevents deep analysis. This creates a cognitive contradiction. How do we resolve this without compromising either aspect? Traditional thinking says, find a balance point, but TRIZ offers more innovative solutions. TRIZ provides 40 inventive principles that can resolve contradictions. Let's examine how several key principles apply to cognitive challenges. Principle 1 is segmentation. Divide an object into independent parts or make it sectional. In cognitive terms, this means breaking complex problems into manageable subproblems that can be addressed separately. For our focus versus awareness contradiction, we can segment our thinking time, dedicate specific periods to deep focus, and separate periods to broad contextual review. This is time segmentation. Principle 10 is prior action. Perform required changes to an object in advance. Cognitively, this means pre-processing information during low cognitive load periods so decisions can be made quickly when needed. Principle 15 is dynamicity. Make rigid structures flexible and adaptive. In thinking, this means creating mental models that can adjust to new information rather than fixed beliefs. Principle 17 is moving to a new dimension. Transition from one-dimensional to two-dimensional or two to three-dimensional thinking. This is powerful for breaking mental fixation. When stuck in linear thinking, expand to two-dimensional network thinking. Instead of a sequence of ideas, create a web of interconnected concepts. This opens new solution pathways. For physical contradictions where something must be two opposite things at once, TRIZ offers separation principles. These are especially powerful for cognitive applications. First is separation in time. The object should have property X at one time and property Y at another time. Our focus awareness contradiction fits perfectly here. Second is separation in space. Different parts have different properties. For thinking, use different mental spaces. One for creative divergent thinking, another for analytical convergent thinking. Third is separation by condition. Change properties based on circumstances. Adapt your thinking style based on the type of problem, analytical for technical issues, intuitive for people problems. Fourth is separation on system level. Individual components have one property, while the whole system has another. Your detailed thoughts can be rigid and precise, while your overall thinking framework remains flexible. Here's a practical question. How can we apply cognitive TRIZ to the challenge of learning new skills efficiently? The contradiction in learning is this. You need extensive practice to master a skill, but practice takes enormous amounts of time. How do we resolve this? Solution 1 uses segmentation. Identify the 20% of sub-skills that produce 80% of results. Master these high-leverage components first through targeted practice. Solution 2 uses prior action. Build comprehensive mental models through observation and study before physical practice. This preloads your cognitive system, making actual practice far more efficient. Solution 3 uses dynamicity. Create adaptive practice systems that automatically adjust difficulty based on performance. This optimizes the challenge level for maximum learning rate. Here's the TRIZ optimized learning path. First, build mental models through observation. Then, engage in targeted practice of high-impact skills. Finally, use adaptive systems to reach mastery efficiently. One of the most powerful concepts in TRIZ is the ideal final result, or IFR. This is a thought experiment that drives breakthrough thinking. The ideal final result asks, what if the function happens by itself, with no cost, no complexity, and no negative effects? This seems impossible, but it's a powerful mental tool. By imagining the ideal, you're forced to question every assumption. Why do we think resources are necessary? What if the problem actually doesn't exist? What if there's a completely different framing? Cognitive example. How do you remember everything important without any effort? The IFR seems absurd, but it leads to insights. Maybe we don't need to remember everything. We need better information retrieval systems. The IFR reveals that the real problem isn't memory capacity. It's information organization and access. This reframing opens entirely new solution pathways that weren't visible before. TRIZ emphasizes using available resources creatively. In cognitive TRIZ, we identify and leverage mental resources that are often overlooked. Substance resources in cognition include your existing knowledge base, past experiences, and developed skills. These are the raw materials of thought that can be recombined in novel ways. Field resources include attention, motivation, and emotional states. These are the energies that drive cognitive processes. Learning to direct and amplify these fields enhances thinking power. Functional resources are your mental models, thinking frameworks, and cognitive habits. These structures shape how you process information and can be redesigned for better performance. Time resources include idle moments, transitions between tasks, and downtime. The brain continues processing during these periods. Cognitive TRIZ teaches how to leverage this background processing. Here are the 4 classes of cognitive resources: substance resources like knowledge, field resources like attention, functional resources like mental models, and time resources like background processing periods. TRIZ includes a systematic algorithm called ARIZ, Algorithm of Inventive Problem Solving. This is a step-by-step process for resolving complex contradictions. Step 1. Clearly define the problem and identify the underlying contradiction. What parameter needs to improve? What parameter gets worse when you try to improve it? Step 2. Formulate the ideal final result. Imagine the contradiction doesn't exist and the problem solves it. What would that look like? Step 3. Identify all available resources: substance, field, functional, and time resources. What do you already have that could be used differently? Step 4. Apply appropriate separation principles for physical contradictions or inventive principles for technical contradictions. Select principles that match your specific situation. Step 5. Evaluate the generated solutions. Do they resolve the contradiction without creating new ones? Iterate the process if needed, often with new insights from the first pass. Let's work through a concrete case study applying cognitive TRIZ to a common problem, creative block in idea generation. The problem: you need to generate original, breakthrough ideas, but your mind keeps returning to familiar patterns and conventional thinking. This is a fundamental cognitive contradiction. The contradiction is that you must access your existing knowledge to build new ideas, but that same knowledge creates mental ruts that prevent truly novel thinking. How do we resolve this? The ideal final result, novel ideas, emerge effortlessly and continuously without mental effort, blocks, or reliance on existing patterns. This seems impossible, but guides our thinking. Apply Principle 13 - do it in reverse. Instead of starting with what you know and trying to extend it, start with random, unrelated concepts and force connections back to your problem. Apply Principle 1 segmentation. Separate divergent idea generation from convergent evaluation. Generate ideas without judgment in one phase, then analyze them critically in a completely separate phase. Apply time separation. Let your experienced mind define the problem, then step away. Return with a fresh mind that doesn't remember all the constraints. This creates productive oscillation. Here's the TRIZ-based creative process flow. Start with clear problem definition, inject random stimuli, engage in pure divergent generation without judgment, then separate critical evaluation. The cycle continues with refinement. An important practical question: can cognitive TRIZ help with decision-making paralysis, where we have too many options and cannot choose? Decision paralysis presents a clear contradiction. Having more options should lead to better decisions, but actually leads to worse decisions, or no decision at all. This is a well-documented psychological phenomenon. The underlying contradiction is that we want thorough analysis of all options to make the best choice, but we also want to decide quickly before opportunities pass. These goals conflict directly. Apply Principle 35 - parameter change. Transform the physical or chemical state. In cognition, this means transforming the decision from choice-based to constraint-based. Change what you're optimizing for. Use inversion thinking. Instead of asking which option is best, ask which options can be definitively eliminated. This reduces the problem space dramatically and breaks the paralysis. Apply Principle 11 beforehand cushioning. Prepare compensating measures in advance. Make decisions reversible where possible or create contingency plans. This reduces the psychological weight of choosing. Let's examine how cognitive TRIZ applies to learning and memory enhancement, a domain where everyone faces contradictions. The memory contradiction. We want to remember everything important, but we also need to forget irrelevant details to avoid cognitive overload. Total recall would be paralyzing. Apply Principle 4 in composite materials. Replace homogeneous materials with composites. In memory, this means creating a composite system, some information in biological memory, some in external systems, each optimized for its purpose. Store conceptual understanding and relationships in biological memory, where they benefit from associative processing. Store detailed facts and data in external searchable systems. This composite system resolves the contradiction. Apply separation in space. Keep working memory small and focused for current tasks. Keep long-term storage comprehensive but organized with efficient retrieval systems. Different regions, different properties. The composite memory system architecture. Biological memory optimized for concepts, relations, and skills, where associative processing adds value. External memory for facts, data, and details, where search and precision matter. Bidirectional integration creates an optimized whole. TRIZ identifies trends that describe how technical systems evolve over time. These trends also apply to the evolution of cognitive systems and thinking capabilities. Trend 1. Increasing ideality. Systems evolve toward delivering more useful functions with fewer resources and harmful effects. Cognitively, this means developing thinking methods that produce better insights with less mental effort. Trend 2. Evolution toward the micro level. systems become more finely segmented. In thinking, this means developing more granular mental models that can represent finer distinctions and relationships. Trend 3. Increasing dynamicity and controllability. Systems become more flexible and responsive. Cognitive systems evolve from rigid thinking patterns to adaptive, context-sensitive mental processes. Trend 4. Transition to supersystem. Individual systems integrate into larger, multi-system solutions. Individual minds connect through communication and technology into collective intelligence networks. Let's explore how TRIZ principles can be applied to design more effective cognitive training programs. The challenge in cognitive training is that exercises must be difficult enough to trigger adaptation, but not so difficult they cause frustration and abandonment. This is the training contradiction. Apply Principle 15 Dynamicity. Create training systems that automatically adjust difficulty based on real-time performance. The system stays in the optimal challenge zone continuously. Apply Principle 9 Prior Counteraction. If you know stress will occur, induce counter-stress in advance. In training, this means pre-strengthening the cognitive skills that will be most challenged during complex tasks. Apply Principle 16 Partial or Excessive Action. If perfect is hard to achieve, do slightly less or slightly more. Use graduated challenges that build capability progressively rather than demanding mastery immediately. Let me guide you through a practical exercise. Think of a cognitive challenge you're currently facing, perhaps learning difficulty, creative block, decision paralysis, or something else. Step 1. Identify your specific contradiction. What two requirements or goals are in conflict? Write them down explicitly. I need X, but X makes Y worse. Or I need both X and Y simultaneously. Step 2. Imagine your ideal final result. Remove all constraints mentally. What would the perfect solution look like if everything were possible? Don't judge feasibility yet. Just envision the ideal. Step 3. List your available resources. What knowledge, skills, time, attention, tools, or relationships do you have that could be used differently? Resources are often hidden in plain sight. Step 4. Review the TRIZ principles we've discussed and select 3 that might apply to your specific contradiction. Segmentation, separation in time, prior action, dynamicity. Choose what resonates. Step 5. Generate potential solutions by applying your chosen principles to your available resources. How would segmentation work here? How could you separate in time or space? Force multiple combinations. Before we conclude, let's address common pitfalls people encounter when first applying cognitive TRIZ. Pitfall 1. Trying to find a compromise instead of resolving the contradiction. TRIZ seeks to eliminate the contradiction entirely, not just balance between conflicting requirements. Don't settle for trade-offs too quickly. Pitfall 2. Applying principles mechanically without deep understanding. TRIZ principles are thinking tools, not magic formulas. You must adapt them creatively to your specific context. Pitfall 3. Focusing on symptoms rather than root contradictions. Surface problems often mask deeper contradictions. Keep asking why until you reach the fundamental conflict. Pitfall 4. Immediately seeking external resources instead of leveraging what's already available. TRIZ emphasizes using existing resources creatively. The best solution often uses what you already have. Cognitive TRIZ is most powerful when integrated with other cognitive frameworks and methodologies. Let me highlight key synergies. TRIZ synergizes with mental models frameworks. Use TRIZ to identify contradictions and limitations in your existing mental models, then rebuild them to eliminate those contradictions. TRIZ enhances deliberate practice by identifying the contradictions in skill acquisition and designing practice routines that resolve these contradictions efficiently. Systems thinking and TRIZ complement each other naturally. Systems thinking reveals relationships and feedback loops. TRIZ provides specific tools for resolving conflicts within those systems. For those ready to go deeper, let me introduce the TRIZ contradiction matrix, a powerful tool for systematic problem solving. TRIZ identified 39 standard engineering parameters like weight, speed, strength, and reliability. Any technical problem involves improving one parameter while avoiding worsening another. The contradiction matrix is a 39 by 39 grid. Find the parameter you want to improve on one axis, the parameter that gets worse on the other axis. The intersection recommends specific principles to try. For cognitive TRIZ, you can create your own contradiction matrix with cognitive parameters like focus, creativity, speed, accuracy, comprehension, retention, and flexibility. Map your contradictions and build solution patterns. Let's synthesize what we've learned about cognitive TRIZ and its application to breakthrough thinking. The fundamental insight of TRIZ is that innovation is not mysterious or random. It follows identifiable patterns that can be learned, practiced, and systematically applied to new challenges. Contradiction should be viewed as opportunities for breakthrough solutions rather than obstacles. Every contradiction contains the seeds of innovation when approached with TRIZ principles. Systematic application of inventive principles is far more effective than random brainstorming or waiting for inspiration. TRIZ provides structure to the creative process. The resources needed to solve most problems are already present in the system. TRIZ trains you to see and leverage these hidden resources creatively. I'll leave you with a final question to reflect on. What contradiction are you facing right now in your work or life where you could apply cognitive TRIZ principles? I encourage you to take just one TRIZ principle, perhaps segmentation or separation in time or the ideal final result, and apply it seriously to a real challenge this week. Document your process and results. What contradiction did you identify? What principle did you apply? What solution emerged? What worked and what didn't? This reflection cements learning. Finally, share your insights with others. Teaching is the best way to deepen understanding, and your experiences applying cognitive TRIZ can help others overcome their own challenges. In conclusion, cognitive TRIZ offers a scientifically grounded, systematic approach to transforming mental contradictions into breakthrough ideas. It's not magic. It's methodology. The path forward is practice, application, refinement, and repetition. TRIZ becomes more powerful the more you use it because you develop intuition for pattern recognition and principle selection. Remember Altschuller's profound insight. Every problem contains within it the elements of its own solution. Proper analysis with TRIZ reveals these hidden solutions. Thank you for engaging with this systematic approach to innovation and breakthrough thinking. May your contradictions become your greatest opportunities for creative problem solving.